Hello, everyone, and welcome to another episode of the Building Better podcast. Today, we have the honor of having Sam Rashkin join us. He is one of the industry leaders in green construction and design. He created the Housing 2.0 program, and he was one of the main writers in the Energy Star standard code. So, Sam, welcome and thank you for joining us.
Great to be here, Gabriel.
So, I think we can start the conversation with what is the Housing 2.0 program here? What's your idea of transforming the housing industry?
The biggest idea about Housing 2.0 is to be disciplined using a framework so that you basically extract all these opportunities for cost savings while adding all these incredible user experiences so you deliver a better home at lower cost. It's just really substantial how much is left on the table, often in the order of hundreds of thousands of dollars per home in that combination of savings and added value. And so I basically go through one experience at a time. There are 5 key experiences, and look how we can apply a framework to get there. And the 5 key experiences are the community experience, the design experience, the performance, quality, and sales. And what's so important is that particularly in the high performance home space or the zero carbon home or zero energy home, whatever name you want to use for really ultra efficient homes, it's not enough to be high performance. The main reason people buy homes isn't to save energy. It's the whole experience has to be leveraged and integrated along with performance. So that's the real essence of Housing 2.0, is giving people a framework of 160 different best practices for extracting all this value and cost savings.
Okay, and when you say about a high performance home, what really does this mean? Is it the home is, saving a lot of energy, or what is your definition of a high performance home?
Well, now that we're building, even by code, very, very efficient enclosures. In other words, the worst home allowed by law is a very good house. In fact, I would submit it's a zero energy ready enclosure if you built to the 2015, 2018, or 2021 IECC. And when you build such a good enclosure, what you have to realize is you're now obligated to manage a number of risks. One is comfort, because you have much more efficient assemblies. You have much reduced requirements for airflow, longer swing seasons, shorter cycles. We can't just keep using the same heating cooling systems and expect the comfort outcomes that every user wants in their new house. Secondly, because the enclosure is so much more efficient, it has a lot more insulation, a lot less airflow. So it has higher wetting potential with the cold surface inside with the cold side surface inside the cavity getting much colder, since insulation blocks heat coming from the warm side to the cold side. On top of that, we have more wetting potential because we have a colder surface. So we have less drying potential with more insulation, more wetting potential with colder surfaces. And so we have to be kind of militant about how we manage vapor and bulk moisture in assemblies. And third, since the enclosure is so much more airtight, we have to be really mindful of managing all the contaminants that can accumulate inside the home. We need a comprehensive indoor air quality system. So that's one aspect of what's happening. And the second aspect is that we know where the future is going. And so we know that homes are going to all electric. We know that homes have to deal with much more increased disaster frequencies and disaster magnitudes. And we have much more constraints on water supplies. And we know that basically everything around homes is getting to the point where they have to be smarter. So when you look at all these future forces acting in housing, and we look at all these constraints on high performance enclosures, that informs for me what is a high performance home. One, it's comprehensive building science to manage all those moisture flows in the enclosure. Two, it's ultra efficient everywhere. Once the enclosure is efficient, all the components and systems inside the home have to be efficient. Third, you have to have comprehensive indoor air quality, source control, dilution with whole house ventilation, and high capture filtration with high MERV filters. So we need all that indoor air quality control. And then fourth, we have to manage all those future forces. So we want a house that's disaster resilient. We want a house that's water efficient. We want a house that is ready for all electric, and a house that's ready to be smart technology integrated. So that's a lot going on for a high performance home, much more than we used to kind of expect in the past, just sufficient and maybe sometimes indoor air quality. We have to, for really truly high performance, all those factors have to be addressed.
Yeah, you bring in an interesting point here that when building a high performance home, we have to risk manage for some of the other components like the moisture flow and the wetting potential. What do you think is the process to managing this new risks that come to high performance homes?
Well, first of all, it sounds like a lot. I'd like everyone to know it's not that hard to integrate all these elements of high performance into a home. But essentially, we need a basic, again, framework of best practices, and we need to not be overwhelmed that we have to do it all at once. We need to be in the path to getting to a comprehensive high performance product when we build homes. So at the beginning, it's very easy. I think everyone should be doing at least Energy Star, Indoor Air Plus, or Zero Energy Ready Home for two reasons. One, they're readily achievable, and two, they have significant tax rebates for the builder locked in for 10 years attached to them. You get a $2,500 rebate for the builder for each Energy Star single family home, $5,000 for each single family Zero Energy Ready home, less for each multifamily unit, but let's not go into the gory details. My point being that that should be the starting point everyone should be moving to as quickly as they can. And that gets you a lot of the building science and the energy efficiency that we talked about, just doing those two certifications. And it includes the indoor air quality as well, because Zero Energy Ready Home makes it mandatory to be certified to Indoor Air Plus EPA's program. And more, we have to be looking at being ready for the future. Disaster resistant. The Institute for Business and Home Safety has a program called Fortified Home that provides really good guidance and certifications for how to meet prevailing disaster risks. So if I'm in an area that's wildfire prone, there are a whole array of best practices that are simple to do for being wildfire resistant. If I'm in a tornado, hurricane zone or wind zone, you want to be impact resistant. And obviously earthquake zones and all the disasters that are prevailing have to be considered. And then again, if you're in a water constrained market, it's scary to look at maps at the water resources, everything west of the Rockies. You have for everything below the Pacific Northwest, you have the San Joaquin River in the northern part of California, and you have the Colorado River, and that's it for that massive amount of territory where so much growth is occurring in the country. So you have to be water efficient in those locations, and everyone should be ready for electric. They're all the things we talked about, but they're best practices. We lay them out in Housing 2.0 that you can readily get on the path to meeting them, but don't be overwhelmed. I got to do all of this right now.
And for code minimum homes in the IECC, the latest version, versus Energy Star rated approved home, really how much is required to achieve this certification? Is there a big jump, or is it a small little changes that you can do in your construction to achieve the Energy Star rated home? And what's the process for a person to achieve it? What documents do they need to submit, or at what point do they get it approved by the Energy Star program?
The improvement in the energy codes has continually reduced the amount of the energy savings you get from Energy Star and Zero Ready, respectively. You're on the order of about maybe 15% savings with Energy Star above the 2021 IECC, and Zero Ready may be 25%. And that means that the cash flow savings from the energy bill is shrinking. And a lot of the value is coming from the other elements that of these programs that ensure the building science is comprehensive, that ensures the cases are already have the indoor air quality. But if I was to tell you the biggest things you have to do above code for Energy Star, it is all the building science control layers. You have a water management checklist, and you also have HVAC. The heating cooling system has a whole bunch of detailed checklists and verifications that have to be done. You want to get to grade 1 HVAC in the HERS rating process, and there's a number of additional protocols you have to do to get there. And on top of that, Energy Star has other requirements that deal with some thermal bridging and so it's just a really good code for really adding a lot of the building science that is missing from the basic energy codes. Where Zero Energy Ready Home is so outstanding is it fills in some critical pieces that Energy Star doesn't do that are really effective, but a lot of mainstream builders may not be ready for. So the ducts have to be inside the conditioned space. You have to do the Indoor Air Plus certification that I mentioned earlier. You have to do some basic water savings measures that are not in the Energy Star program. And I expect that the Zero Ready Home program will also start integrating in the next iteration a number of resilience requirements, also to start addressing disaster risk as well. And all of these things are addressed usually by checklists or some other forms that are used by the HERS rater to complete the certification process. So without walking you through all the forms, no, it's mostly the building science and a little bit of thermal performance improvements with Energy Star certified home. And with Zero Energy Ready Home, you're really doing some significant important additions. We're bumping up the energy a little bit. The ducts are in conditioned space. You're starting to address indoor air quality. You're adding some of the missing pieces we talked about that comprise a comprehensive high performance home solution.
And do you see, Sam, like in a not so distant future, the energy code standards becoming the just the standard code that everyone needs to achieve, just like the minimum required, that every home has to have this standard? Because we've seen how the codes through time have improved and become more strict to turn homes more energy efficient. So you see this happening sometime in the not so distant future?
Yeah, I think what I always envisioned when I came to EPA, really right about just as 1995 was getting started to start that program, I always hoped and envisioned that Energy Star was a program where we would work ourselves out of the job as we proved the business case for how compelling it was to build high performance homes. And the codes would just have to eventually marry up to them because our numbers and success was so great. You couldn't argue that they weren't cost effective, much more cost effective than past code, and finally become code. And to some degree that has happened and we're getting there. For now, like I said, the Energy Star and Zero Energy Ready Home programs have two main functions above code. One is to ensure that builders don't get in trouble building high performance enclosures by addressing these other risk factors, building science, comprehensive, quality installed heating, cooling that knows what to do with ultra low load homes, and comprehensive indoor air quality. So the certification programs ensure those critical risk factors are being managed. And if you ask me what is one of the biggest benefits for builders to be certifying to these programs, it's risk management because of, again, all the factors I've laid out several times. The other opportunity for the codes is this. Codes are one thing, often when they're adopted, it's with a lot of amendments that really can significantly reduce the rigor of the intent of whatever version of code was adopted. So you can adopt 2021 IECC with a number of amendments and dilute a lot of the intended energy performance that was in the code as it's written. And then on top of that, you have the enforcement of the code. If you look at how the building inspection process works, building inspectors don't have the bandwidth to do rigorous oversight to make sure all elements of the code, the IECC codes, are being enforced. So what the certification programs do that adds tremendous value is with the HERS verification process, now our confidence is much greater that you're getting what's actually specified in those programs. And a lot of what's specified sometimes is just emphasizing what's in the code so that it is being verified. So, so the two benefits are the code isn't adopted often with all the measures and provisions that ensure the highest performance levels. And second, the enforcement process that often is missing with just a building inspector who can't realistically be expected to do the kind of verification a rater would do, gets done and is critical to ensuring the homes are quality built. So when you ask what codes basically marry up to the Energy Star program and certification, the only way they get there is if they also maybe adopt some, like just also adopt the HERS verification process, because building departments are not equipped to do that.
And I agree with you. Here in California, we have the Title 24 Energy Code, and a lot of times the requirements are based on R values of a wall assembly, but the wall values are not taking into consideration all the thermal loss and all the thermal breaks around that wall. So it is definitely a very inefficient system that it's not proving for a good high performance home compared to, actually doing a HERS rater, which comes in and
Yeah, I always have issues with the California Title 24 code because it's overly precise. And then it misses some of the big picture items like you mentioned. Does it really account for the full benefit of like a SIP wall that is incredibly robust, managing thermal losses and providing extra strength and extra durability? There's no way that the code knows what to do with it. On top of that, they have 16 different climate zones for one state. I have 16 climate zones for the entire rest of the US with the IECC code map. So California has 16 different climate zones, and it's insanely overcomplicated. On top of that, it's also there's also a question of what they are requiring. Can it be adequately enforced by the building departments? And so they don't have the verification protocols, I think, to really oversee it the way it probably needs to be. It's a fairly complicated code. And lastly, it's what you're saying, though. It's also, are we specifying the right things? Are we not blocking innovation? It works probably better, but gets scored lower because the codes don't know what to do with them.
I know, Sam, that you're also a big advocate for SIPs because they really hit on many of the points we've been talking right now, considering the disaster affected areas, also the high performance homes. So can you give us a little bit about what's your thought on the SIPs? Why has it taken so long for them to hit the mainstream market? And do we see them in the near future, crossing this chasm to become like more adopted in the whole construction industry?
Before I go into why are more SIPs out there and do I see them gaining market share in the future, let's lay out just how compelling an enclosure is, and then then ask the question, why, if it's that compelling, why is it not happening? So let's take that approach. So when you buy a SIP enclosure, understand you have two sheathing layers. Usually it's OSB. It could be magnesium oxide board called mag board. It could be any number of materials. I think I've seen a new agriculture-based product made out of corn husks. It could be fiber cement. It could be polycarbonate. But basically, all SIPs have one common feature. It's a structural sheathing layer, outboard, inboard, and then it's sandwiched around foam, usually expanded polystyrene. It could be extruded or it could be polyisocyanurate. But essentially, it's a sandwich panel. And what happens is the structural engineering dynamics of a skin structure and large panels all around a structure is that it's stronger, more impact resistant, and much more thermally resistant because you have much less thermal bridging. And it's impossible to have any vapor flow through the assembly. Because the sandwich is so significantly pressed and sealed to each side of the foam, there's no pathway for any moisture flow. So all the risks we talked about with cold surfaces and less drying potential, all that goes away. You take rid of all that risk with a SIP assembly. Then if I use SIP for roofs, I eliminate all the egregious Swiss cheese of holes and penetrations and cracks between the attic, that's unconditioned if it's vented, and the house. And I wind up with all that useful space for MEP, for storage, or for other additional rooms if the slope is high enough and creates enough volume. So you have all the additional useful space, and you get rid of all the air sealing and air barrier details between the house and the attic, and you get rid of all the venting, and it's stronger, and it's also just more efficient. So this is a pretty crazy amount of advantages that the technology has, which begs the question, why is it not, to your point, being adopted at a higher rate? And here's where I'll suggest it's the biggest challenge is you can't cross the chasm with conventional builders and their business model that they don't own any part of the construction process. So a typical builder basically buys land, have some offices, and they subcontract out everything to do with construction. They don't own the labor, they don't own the equipment, and that's all on somebody else. So when we ask a builder to use SIP panels, they have to get someone else often to install those panels and make sure they're trained and the electrician knows how to do the wiring with SIPs. It's no more difficult, but it's different. And so that, for whatever you want to call it, that's friction if they have to learn a new skill. And so we give builders only a part solution instead of a whole product solution when all we sell is the panels. And so where most manufacturers don't have setup crews and do the installation, it means the builders have to find a framing crew that knows what to do with SIPs or train them to use the SIPs. And I think a lot of the forces constraining more use of SIPs would be mitigated if you can just go to a SIP provider and they would do everything for you. They come, they set up the panels and do all the work that's needed. Even better if they provided the interior walls, so you didn't need a framer just to frame the interior walls. And in a market reality where workforce is shrinking and 95% of builders are struggling to find workforce, it's great that SIPs are faster and better and require less cycle time and less labor. But I got to find a framing crew that will just frame the interior walls. And often they'll say, "No, what? I'll just go to the other builder down the street who wants me to do the exterior and the interior walls." And it becomes harder to be in front of the line to get the limited framers out there to do a much smaller part of the pie. So to some degree, it's the clashing business models of a typical SIP provider just wants to sell panels, and a builder wants just to buy land and have the least burden to get the home constructed and just hire other people to do whatever easiest. And that's usually the typical construction.
I think that's a great point you bring in, and that's what we're trying to do here at Preflex now is not just sell the panels, but also include all of your framing materials as well as the installation. No, we just brought on a new person in our team, so here in Preflex we can offer the whole framing installed anywhere in the United States. So we're very excited to bring that into the industry and really help, because what you say, it's a clash of the business models, no one wants half a house or just a material and not install it. So that's what we're really trying to hope we can bring into this whole industry and see and try to accelerate the adoption of the SIPs.
So Gabriel, if I can throw in a third factor, which I don't want to, I want to make sure is not left out, but is so important. The other thing is SIPs cannot be an afterthought. You can't go around designing homes and then go to a SIP provider and say, give me this house. SIPs are amazing, but they have certain design factors that help minimize their cost based on how they're made. So for instance, a lot of open layouts, you have to figure out where do I have a place for a post so I can support a ridge beam so I don't need to have separate trusses to hold up the SIP roof panels, that kind of thing, for instance. Or what dimensions should I use that for openings and for walls that align with how the panels are made. The point I'm making is you have to have SIP in mind at the very beginning when you design a house, because the cost reduction potential, 30, 40, 50% is substantial when you have a SIP optimized design. As you know, I've developed for the Structural Insulated Panel Association a SIP true cost bidding tool. And what we find when we run the SIP true cost bidding tool is that if you have a SIP optimized design, SIP's cost savings and added value blow away conventional framing almost every time. Not just a little bit, they blow it away. So we have to, when we talk about what another barrier to what's constraining SIPs is the design process usually starts with some designer or architect just putting plans together for a builder. There has to be a thoughtful understanding of SIPs and how they're made to design the homes. You'll get just as beautiful a home, but you will be accommodating the actual process and how SIPs are made and installed to avoid lots of extra costs.
Yeah,
One reason by way that your ADUs are so compelling is because it, by almost definition, an ADU, a small, simple box, is just ideal for SIPs.
yeah, we have seen a big increase of the ADUs in with SIPs. Also, the multi ADU projects, like we're doing a couple fourplexes, even some nineplexes that are all ADUs. So we're like we're able to penetrate the ADU market. And since then, we have expanded. We're doing a lot of multifamily and commercial projects as well. And what you bring up is a great point on the design considerations. A lot of times we get sent a project that is already engineered for stick framing, and together with our expert team, we're able to give them some design consideration to optimize and value engineer the project to lower the cost, because SIPs also have lumber. It is 60% less of lumber, but they do have some lumber, and there is some ways that it can be reduced, considering some design criteria that can make sure the panels perform to their optimal structural capacities.
Yeah, Gabriel, I love everything you're doing. The fact that you're working to get SIP optimized designs, the fact that you're integrating the setup and the additional framing, so you virtually eliminate the entire framing trade from the builders. nightmare of trying to find workforce, you are doing everything right that way. Because that is just will set you up to be, again, so substantially reducing friction and uncertainty for the builder. And that's the key to crossing the chasm. So I'm great. I'm really happy to hear all that. That sounds perfect.
No, that means a lot coming from you, Sam. I really appreciate it, and we couldn't, do it with all the help that the association and yourself has given to us. And also, it's a result of going through that friction you mentioned. Like we have done projects, we've seen the friction there is between the framer, the engineer, the architect, the manufacturer. So how can we, help this friction is solving all these problems for the builder, and they have a finished installed framed on site so they can have all their specialty trades move forward. And it's also easier for the specialty trades because now they have a continuous sheathing both sides. They're able to attach anywhere, still reducing their amount of waste and time for their specialty trade. So I really think we're on the right track, and I'm very
That's
excited to what the future calls for us.
Yeah, that's great. So the last part of the answer is where do I see SIPs in the future? And the answer for me is SIPs has been stagnant for a long time, but offsite in general, all the options, panels, modular, hybrids, even some 3D printing. Right now, all those offsite solutions are only 3.5% of all the housing constructed in the country. I think it's going to grow to about 20%. And SIPs is going to get a pretty big chunk of the offsite market growth. Again, we've hit a wall. For every 5 workers retiring out of the construction industry, only 2 coming in behind them. And the average age of a worker in construction is 42.5. That all means we have a tsunami of workers retiring out of the workforce. And we have a kind of just a dribble of replacement workers coming in behind them. So my prediction is all these offsite options become an imperative. You just won't find the workforce. And at some point, you'll start considering the true cost. The reason that why SIPs is being undervalued right now is because it's just simpler for builders to use the same contract relationships, the same framers, and not to do the hard work figuring out the true cost. The true cost bidding tool makes it so simple and elegant and makes it so clear about all the cost advantage elements that are missing when builders consider advanced wall assemblies today. So again, I figure about 20% of the market by 2035, 20 or less will be offsite, and figure SIPs will be a good chunk of that 20%.
I really hope so, and I look forward to that, Sam. And also something that can help accelerate that, and something we've talked about is, you know, improving the codes in terms of, getting them the code minimum standard to be, and the criteria we always talk about is the air changes per hour, the HCH 60. If we can really make this like a requirement more than the R value in a 1 foot by 1 foot section of a wall assembly, this can also really accelerate not just the SIP industry, but the actual high performance homes being a standard like nationwide.
Well, I think we can do also a better job translating the value of these airtight homes like the SIP homes. If you look at all the requirements for Energy Star, Zero Ready, all the various codes in Passive House, you can go crazy with the kind of the spaghetti of ACH 50 numbers that vary by climate zone, and I think it's insane how over complex we make it. Right now it varies from like 1.5, well, it varies from 0.6 for Passive House to, you can go up to 8 or 6 ACH 50, so almost a 10x variation. What I believe is every single home built in the country should be built 1.5 ACH 50 or less. This is 2024. We know how to build an airtight home, And all this Swiss cheese of different numbers and values for climate zones is based on controlling thermal flow. But that's only one element of why air tightness is so important. Air tightness is also important for two other reasons. One, wellness. When you have an airtight building, it's amazing how much better the indoor air quality is. Dust, pollen, pests, smoke, moisture not get inside the home because it's airtight. So it just lives better. It's so much healthier to have an airtight home with matching whole house ventilation, size for the number of bedrooms and occupants. On top of that are the resilience benefits. When I have a SIP home with a SIP attic, now there's no place for embers to fly into an attic through vents because there's no attic vents. There's no way for smoke to infiltrate the house through excessive air leakage. It's stronger for impact. It's incredibly strong for earthquakes. It's just a more durable, resilient home. So I'm getting thermal control, wellness, and I'm getting resilience by doing air tightness if I do 1.5 or less. So just do it. It's almost a no-brainer with assemblies like SIPs. You have to really be working hard with a SIP home to go above 1.5. It's visually obvious, and you're dealing with big monolithic panels that are much easier to assemble airtight. And the big operative word I used was assemble versus construct, because that's all you're doing. You're assembling big panels in the field. You got foam where the two panels meet, then you have two splines often, and then you tape the joints. You got belt suspenders and another set of suspenders. It's so airtight inherently. So stop the madness. Everyone 1.5 ACH 50 or less. Forget all the tables and requirements and variations and Energy Star zero ready in the codes. Just everyone get to 1.5, and it's a no-brainer. It's you have to just be trying to do something bad to get above it when you use advanced wall assemblies like SIPs.
Like today, Sam, for our listeners, what is the traditional stick frame home ACH 60?
I'm going to guess it's somewhere around 3 ACH 50.
3 ACH 50. So that means it changes air 3 times every hour. That is double what a just minimum SIP home can achieve. So
Yep, exactly. It's only that if the code enforcement process is watching the builders. And, I don't know if the California code requires air leakage testing and duct leakage testing the way the certification programs do. But even there, it's hard to enforce all the time. You just take it out of the equation by using better advanced construction.
yeah, I agree with you 100%. That's where we
You
need to
would
go.
make a SIP panel.
Yeah, we do, Sam. And I think we covered all the topics. I don't know if you have any closing thoughts or anything that you want to bring up.
Just this. If people listening to this podcast, the chances are that like 95+% of them are already in the choir. They already are believers in high performance construction. So I want to get back to the housing 2.0 part of the equation. I want to say is it's great that we can build these great high performance homes with these great advanced construction technologies. But please don't forget how important community is. Community has such huge impacts on wellness, on health, on ensuring future value. The choices we make on how we build communities is critical. Design is imperative. People really care about design. You can't ignore design with too much focus on performance. You have to dedicate tremendous amount of diligence to do really good designs. And Housing 2.0 does a great job laying out the simple tools you need to make great designs. And then you do the performance we mentioned, and then you have to build a quality product. And that's where, again, these advanced technology systems have to be considered by so many more builders because the quality difference is not even close. And finally, on the sales side, we have to be better translating the value when we do all this. If we have great communities, great design, great performance, and really outstanding quality, we have to translate it so it is crystal clear to the buyers. And this is where I live, in trying to get all 5 experiences integrated into a single superior product that is a home that lives better. After all, home is where life happens. We spend 70% of our day in our homes. That is where life happens. And let's make it happen better. So that's my closing statement. Thank you, Gabriel. It's always, always enjoy talking to you.
No, thank you, Sam. I do as well, and thank you for sharing all your knowledge with us and with the rest of our listeners. And I look forward to keep trying to, transform the housing experience for all the all over the country and beyond. So again, thank you so much for your time, and I really do appreciate it. Thank you.
You see it.